Hello everyone. Today class number 20 for electrical machine 2. Class 20 for electrical machine 2. Okay. So today I will do a numerical regarding the test of three-phase induction motor. Okay, today I will do a numerical regarding the tests of a three-phase induction motor. So numerical regarding tests of three-phase induction motor. Okay, so problem, only one problem. Okay, only one problem I will do. Okay, so write a 400 volt comma 3-phase delta connected induction motor gave the following results. On no load test and short circuit test. That means no load test and short circuit test you have to perform over here, so to understand this type of data. Okay, so the no load test data and short circuit test data. So no load test data is 400 volt 3.0 ampere, that is 3 ampere. 3.0 ampere is 3 ampere. No need to write 3.0, it will be 3 ampere. And 645 watt. 645 watt. Okay, this is 3 data is given for no load test. And now for short circuit test, 200 volt 12 ampere and 1660 watt power. Okay, so next write the friction and windage loss. Now write continuously the friction and windage loss amounts to 183 watt. Okay, amounts to 183 watts. Determine the energy and the magnetizing components. Determine the energy and magnetizing components of the circuit, and also calculate R naught, X naught, R1, X1, RM, XM, assuming 400 volt is applied across the stator. 400 volt is applied across the stator phase. Stator phases, and stator resistance, that is R1, assumed to be 5 ohm. R1 assumed to be 5 ohm. Okay, so this type of question is frequently asked, okay, in your exam purpose. So now we have to perform the test for starting for no load. Okay, so make a heading no load. So for no load you have to applied voltage. What is the applied voltage? See, this is the applied voltage, 400 volt, right? Okay, so line current is what? This is a line current. Three ampere. Okay, so phase current equals to what? As it is a delta connected, so as it is a delta connected, the relation between it will be what is the relation? 3 by root 3, that is the phase current IPH equals to line current IL by root 3, right? So this is your relation, that will be root 3 ampere. Okay, so phase current is root 3 ampere, therefore phase current equals to root 3 ampere. Okay, so for directly you can calculate no load power factor. What is no load power factor? Cos phi naught, right? No load power factor cos phi naught will be equals to what? Your Pi divided, the formula was Pi divided by V into I naught, right? So Pi equals to what? Pi equals to your 645, that is this amount of it is 645. Okay, it is 645. So 645 minus, that is copper loss. Copper loss means what? PCU, right? And the windows and friction loss, that is PWF. Okay, so beside it, so PCU equals to what? 3I square, 3I naught square into R1, right? 3I naught square into R1. So 3 into I naught equals to what? I naught equals to root 3 whole square, that will be 3, right? So root 3 whole square into phase current, root 3 whole square into R1 equals to, assume to be 5 ohm. 5. So let us calculate. So it will be 3 into 3, that is 945, right? 45 watt PCU, and PWF will be directly given to you, that is loss is said to be 183 watt, right? And P of WF equals to 183 watt, it is given. It is given. So if we put over here, so it will be 45 and it will be 183. So your result will be, so V equals to what? Your V equals to 400 and I naught equals to 1.732, that is root 3. So for that is 600 minus 183, that is 447. Sorry, 645 by minus 143, that is 417, right? 417 divided by 3 into 300 into root 3. So your after calculation you can get it will be 0.2. Okay, so this is one of the answers. Okay, so no load power factor is sometimes it has been asked. Okay, so this type of question may have been asked, so that's why I am concluding over here. So that is the question number 1. Okay, so no load power factor may be asked. So in this question there is no question about the load power factor, but you have to find the another terms. Okay, so this is your first part, this is the first step to find the no load power factor. Okay, so next one, Roman 2, right? Energy component of no load current. Energy component of no load current. So what is the energy component of no load current? That is IE. IE equals to, or IE naught equals to, you can say whatever the current, line current, so it will be multiplied by IL naught into cos phi naught, right? This is your formula. So IL, this is IL naught. Okay, that will be equals to 3 into cos phi naught equals to 0.2. that is 0.2, that is 0.6 ampere, right? So the energy component of no load current equals to 0.6 ampere. So now third one, energy component of no load phase current. Energy component of no load phase current, that is IEPH naught. IEPH naught equals to 0.6 divided by root 3, that is 0.6. The energy component of third one, energy component of phase current, phase no load current. That will be equals to IPH naught equals to what? IPH naught will be equals to IE naught divided by root 3. Okay, so that will be 0.6 by root 3. The answer will be 0.3464, 0.3464 ampere. Okay, so this is your third one. Now I will move into the fourth one. Fourth one, that is magnetizing component of no load line, no load current, no load line current. What will be the magnetic component of no load line current? So I M naught equals to root over of I E naught square minus I naught square minus I E naught square. Okay, so it will be equals to 3 square minus 0.6 square. So that will be equals to 2.94 ampere. Okay, so fourth one is completed. So now fifth one, fifth step. So fifth step is magnetizing component of no load phase current, no load phase current. So which will be equals to whatever the value IMPH, which will be equals to IM naught by root 3, that is 2.94 by root 3 ampere. Okay, so what will be the answer? 2.94 by root 3, which will be equals to 1.697 ampere. Okay, so this is the fifth part. So now I will move into sixth part, no load resistance. No load resistance means what? R of E. Okay, R of E, you should calculate R of E equals to V by IE. Okay, V by IE, that will be equals to what? That will be 400 by IE equals to 0.3464, 0.3464. So your answer will be 1155 ohm. Okay, so the no load resistance RE equals to 1155. This is one of the parameter. Okay, so now sixth one, X naught, that is no load reactance, no load magnetizing reactance, X naught, which will be equals to, or you can say XM. Okay, you can say XM V by IM. That this is, here you have to find RE and XM. Okay, this is RE and this is XM. Okay, V by IM, that will be V equals to what? 400 by, and IM equals to 1.69, right? 1.697. That will be equals to 236 ohm. So these two parameters you have to find. Okay, so these 7 points you have to do for no load test. Now I move into the short circuit test. Short circuit test. Okay, so what is short circuit test? Right, On short circuit, that is VSC equals to what? 200 volt. Okay, VSC equals to 200 volt. And ISC equals to what? 12 ampere. And PSC equals to 1660 watt. Okay. So this is a line current, short circuit line current. Okay. So short circuit phase voltage, short circuit line current. Okay, so short circuit phase current equals to what? Short circuit phase current IPSC equals to 12 by root 3. That will be how much? That will be 6.928 ampere. Okay. So next one, short circuit power factor. Short circuit power factor equals to cos phi SC equals to Pi by same formula 3V SC into ISC, right? 3VSC into ISC, IPSC, obviously IPSC, that will be equals to Pi equals to 1660. Here it is given directly. Okay, there is no need to subtract anything. So here you have to find directly. You can put for short circuit test. Okay, for short circuit test you can directly use this one as a Pi. Okay, so VSC equals to, that will be 200 and 2, that will be 6.928. okay, so this is your power factor. So after calculating it will be 0.4 power factor. Okay, so this is your for Roman 1, and now Roman 2, that will be equivalent impedance. Equivalent impedance will be equals to Z01 or Z01 will be equals to VSC by IPSC. Okay, VSC by IPSC. So Roman 2 equals to Z01 equals to VSC by IPSC. VSC equals to what? VSC equals to 200 and IPSC equals to 6.928, right? So this will be the ohm, that will be the answer, 28.87 ohm. Okay, now third one, that is equivalent. This is equivalent impedance. Now equivalent resistance. Now equivalent resistance R01, which will be equals to Z01 cos phi SC. Okay, so Z01 equals to 28.87 multiplied by cos phi SC equals to how much? It will be 0.4, right? So your answer will be 11.54 ohm. 11.54 ohm. Okay, and now fourth one, equivalent reactance. Equivalent reactance X01 equals to root over of Z01 square minus R01 whole square. Okay, so that will be equals to 28.87 whole square minus 11.54 whole square. Okay, so your result will be how much? It will be 26.5 ohm. Okay, 26.5 ohm X01 equals to. And now short circuit current at normal voltage. Short circuit current, then fifth one, short circuit current at normal voltage. Because in this case, when I am calculating for 200 volt, right? So now you have to find the short circuit impedance, short circuit current, that is ISC, at 400 volt. Okay, that will be 12 into 400 by 200, right? So here you have the data is for 12 ampere is for 200 volt. Now if we apply the 400 volt over here, so it will be 24 ampere. Okay, so these 5 answers. So previously it was 7 answers, now it is 5 answers. So these type of answers. So whatever the question is being asked, so you have to perform the step by step this and maintaining this formula. Okay, and maintaining this formula you have to do the step by step. Okay, so this is all about of the numerical regarding tests of 3-phase induction motor, and up to this much this module is completed. After this one, the module is completed. Now I will move into the problem module number 4, the single phase induction motor. Okay, so from the next day I will start with single phase induction motor. So this module up to this much, and waiting. So thank you for waiting for next class. Okay.